Welcome back. Well, I'm not exactly sure where people are. It's possible you had a day off and didn't tell me. I guess that's happened before. But in any case, that's fine. I'm going to go ahead and record this week because next week in the United States is Thanksgiving. So maybe I'll record this week and not next week, and whatever. We'll try and get things caught up. In any case, we're getting close to the end of the semester, so we have a few more things to wrap up before we move along. I'm almost finished grading the ChangeMaker projects, and I don't want to start with a bummer, but there was one kind of small thing that bothered me and one really big thing that bothered me, so I want to tell you about those things. First, for the small thing. So I saw in much of your code a line that looked kind of like this. Now, that line, it actually does something. What does it do? Okay, even if you wrote it, you probably can't tell me what it does, because what does it do? It does like 6 different things. And in software engineering, which is a class you haven't taken yet, but software engineering is that art of making your code not only work, but work well and be usable. This would be the classic case of what we call a code smell. Okay, so code smell is this, right? The code, it may actually work, but it doesn't smell good. You know, ew, right? That's exactly what's going on with this code here. Why? Because it is doing a lot of things. And not only is it going to be really, really hard to debug, it actually is making it harder for your code to act properly. In fact, it isn't working correctly, and this hurt a lot of you in your final project. That leads me to the really big thing. The really big problem is that I saw several of you use exactly the same line of code, which means I don't think you were working alone, and that disappoints me greatly. Very, very greatly. I love for you to cooperate together, but you cannot turn in the same code, especially if it's wrong, and this is wrong. Now, what's wrong with it? Well, it's too complicated to even tell. I'm really good at this stuff, and I had a hard time understanding this code. Okay, let me show you an alternate way of writing the same thing and see if you can figure out if this makes more sense. Okay, so I'm going to do something like this. I'm really thinking through my algorithm. Sorry, what language am I in? Let's assume that I have I right now, which is a position in plane. So I'm going to find character of plane at position I. And then I'm going to find location of that character in alphabet. And I'll put that in a variable I'll call position. I'll just call this, I don't know, Mike or something. Okay, and then what am I going to do? Then I'm going to find corresponding character in key, and I'm going to store that in, we'll call that new char, and then we'll append new char to output. Okay, that is the logic that we're trying to do. Would you agree? Okay. What is the relationship between this line and this logic? Well, it's horrifying, isn't it? Yeah, you can't even tell. Even if you know the logic, which, by the way, isn't completely correct. Even if you understand this logic, getting from that logic to that line is really, really tricky. Now, what did we do? We saved some space in the editor, but we really didn't gain much. I mean, because it's not real space. It's not like we're really printing things out. So now I'm going to break it down into how I would recommend you do this. Char, my char gets, let's see, plane.char at I. Now, that is the piece that happens right here. But I'm giving it a name. I'm giving it its own line of code. Okay. Now we'll take a look at this piece. Okay. Find the location of that char in alpha. Well, I'll do this. Int position gets alpha dot index of my char. Now, this is the part that's buried in this little piece, sort of. But you see there's like 3 levels deep. Yikes. Actually, that's not even right. This is the one we're looking at, alpha dot. Yeah, it's not even. Okay, so in any case, I'm looking at the alphabet, finding the position of that character in plain. And, oh, that's for the debug. No wonder. There we go. So that, sorry, I just copied this from somebody's code. In the end code, it would look like this. So again, you can see how difficult this is to debug. I couldn't even figure out what was going on when I actually knew exactly what was happening. All right, so position gets alpha.index of my character. Okay, well, all right. Now we find the corresponding key. So char new char gets key dot char at position. Sorry, I'm in Java. And then output plus equal new char. Now, here's what I'm saying here. These 1, 2, 3, 4 lines of code does the same thing as this 1 line of code. Well, clearly, if you can do it in 1 line of code, that's way better, right? No, it is not. It is not, it is not, it is not. Making your code brief and short is not the goal. Making your code understandable is the goal. But wait, Mr. Andy, you used 1, 2, 3, 4 unnecessary variables. Right, I sure did. Look how worried I look. I'm not worried. Why? Because I'm inside a function. They'll go away soon anyway. I am much more concerned about code clarity than I am about shortness. And there's another problem, a big one. First of all, make sure you understand, can you easily see the mapping between the comments and the code? I think you should be able to see that pretty well, right? Much harder to see that when we jam it all into 1 line. Here's another very practical thing. If you have one very complicated line of code, which line of code is going to break? This one. Just promise, because there's just too many dependencies. There's too many things that can go wrong in that 1 line. And so you get an error message on that line, and what of those 5 things we were doing there is wrong? Is it the error? I don't know. All right, so if I break it up this way, and one of these is wrong, and they could be, well, where will the error message happen? On the line that is incorrect. And I've got the comment right above it, so I know exactly what it was I was trying to do, and I can compare what I was trying to do with what I really did. But then here's the bigger problem with this. And the bigger problem with this is it turns out that when you test this, it's not going to work correctly. It's going to give you troubles when a character does not show up in the alphabet. And here's the big problem. When you have code that's this brittle, you realize you need to change your algorithm. You need to tune up your algorithm. And you're looking at this line, you're like, I'm not changing that. There's no way I'm changing that. I barely understand it as it is. Okay, here's the real problem. If we look for the position of something in the alphabet, if that thing wasn't in the alphabet, the position we get back is what? So you may have to look at the index of method again. When you look at the index of method, you'll find out that if that thing wasn't in the alphabet, we get a -1. Now this explains an error that many of you were getting. When we try to go find the character at position -1, there is no character there, and it will crash. Now, because we've got our lines broken up, we can see what's going wrong here. When this line crashes, and it did if you had a space, or a number, or a punctuation mark, or something, then you would have no idea what part of this monstrosity was wrong. But here we kind of know exactly where the problem is. It can't do that piece. And that piece is this piece, which also includes this piece and this piece and this piece. Do you see why it's so much harder to debug? Much, much harder. So when you break it into separate lines, it's going to be much easier to debug. And so now we can now we know that we can think through our algorithm a little bit. How about we say this? If, and I'll just do it as an algorithm again, if it is a legal character, that's what we really want to do. Then we'll do this stuff. Otherwise, we'll just skip it. Does that make sense? Again, because my algorithm is broken into much smaller steps, it's much easier for me to append the algorithm and modify it when I discover there's a problem in my logic. So I would now, how do I say it's a legal character? Well, the position is not -1. So if position is not equal to -1, then do all these things. And then we end the if. This is a very easy way for us to simply skip any characters that aren't in the original alphabet. Oh, big lesson there, isn't there? Yeah. So you never want a line of code that does a million things because it's going to cause you problems. Whenever you see something like this, you say to yourself, code smell, ooh, that stinks, not doing it. Break it into several smaller chunks. And then you go through line by line of your algorithm. You want each algorithm to do one thing alone, and you want each line of code to do one thing alone. Or you could do two things when it's, we find something and assign it. But you don't want any line of code to do more than one or two things, pretty much ever. Because that's just going to make things much more complicated when you find you have to adjust your algorithms and when you find that something has gone wrong. So we separate things out into smaller lines that do atomic things. They only do one thing. And that's going to make it much easier for us to write code that does what we want it to do. I'm sorry, let me close my email so it stops bothering us. So from a very practical point of view, as soon as I see code like that, it makes me nervous because I think that's going to break and it's going to make it harder for you to make your code work correctly when you combine that much. And this is exactly what I saw in your cryptos. I saw more than half of you had exactly the same problem in your code, and it all came down to having a line that was too complicated. That's bad, but it's not really bad. Here's what's really bad. I don't know which of you, if any of you, actually wrote this line. I don't know if one of you wrote it and everybody copied it. I don't know if you found it on Stack Overflow. This looks like a Stack Overflow thing. This is the sort of thing that they would do there. And that's part of the reason I hate that site. It's really common for people there to show off by making really way too complicated lines. I'm glad they do because then I can tell when somebody's copied it. But that's my guess, is that one of you found this on Stack Overflow or something and said, this will work. And then everybody else was like, crap, I got to turn something in. How do I do this? So I am not upset that you use smelly code. I am very upset that perhaps you didn't all write your own code. That makes me very, very upset. Because, see, I'm not here to simply, get you through this thing. I'm here because I want you to learn how to program. And you've got to do it yourself. I would much rather you write bad code that's yours than good-ish code that you don't understand. Because you're not going to, I can tell you, the next class is harder. The next class after that, harder. Ask your friends that are taking some of my other classes right now. It does not get easier. And if you can't really own your own code at this point, you're going to have a lot of trouble when it gets more difficult. You okay with that? All right. So I did not this time fail all of the projects that look too similar. On the next assignment, if I see projects that look too close to each other, you may work together in your algorithms, but you have to write your own code. If I see code that looks too similar, I will give both projects a 0 until you talk to me. I'm very serious about this. I'm trying to make sure that you are held to exactly the same standards as the Purdue students. I mean, I teach in one of the most well-known computer science programs in the world, and I think you're just as smart as my students here. And I'm going to hold you to the same standards. You write your own code. Be wrong. It's okay to be wrong, but do your own code. I would much rather you have mistakes that are your own than working code that's not yours. Does that make sense? Okay, this is unpleasant, so let's move on to something else. Should we do that? Okay. All right, so today I want to talk a bit more about how we add various other components to Swing. So, you know, we started to build a GUI, and that's kind of fun. We're getting close to our final project, so I want to work a little bit on how do you add various components to a Swing a Swing-based application. So the first thing people often ask is, okay, you showed us how to work with a button. And that's true, I did. Actually, let's get rid of this guy because it's really confusing everything. No, don't say that. Okay, so let's do this one. I think I've already compiled it. All right, so here I have a program, and it has a bunch of buttons on it. Ichi, ni, san, shi. Yeah, I grew up in Japan, so we're counting in Japanese. Okay, so here we go. That's pretty cool. Now, up till now, we did know how to set up that layout. We do know how to add a button. We know how to do an event handler. We know how to modify a label. All of those things are happening here. But one thing is happening that's actually really different, and that is that we have more than one button. And I've seen a lot of different approaches to this, and some of them are kind of horrifyingly difficult. So you got to be really careful. When you see code online, I see a number of different solutions. Sometimes people will actually create an entirely separate event handler for every button. That's more difficult than it needs to be. I'll also see sometimes something called an anonymous inner class, which is also much more complicated than it needs to be. And that is, as soon as they see a button, they immediately build a little inner event handler just to handle that one button. Well, that's fine, but it really is more complicated than it needs to be. I'm going to show you a much simpler approach, which makes it much easier for you to handle any number of buttons or other actions on a form. All right, so let's take a look at this thing, and you'll see I have a label for output. I have buttons 1, 2, 3, 4, and then here's my initializer. So get the content pane, make a new grid layout 0, 1. Remember what that means? One column, as many rows as you want. And my main panel is really the only panel here. I'm going to add the label and all the buttons. Now recall that adding a button is easy enough, but it won't actually do anything if you don't add an action listener. You have to tell it, where will I find the method that I should respond to when we click it? So for each button, we need to add an action listener. Why am I adding this as an action listener? Well, look back at the beginning. We extended JFrame and we implemented action listener. If you recall what implementing action listener means, it means we have promised to have an action performed method. In fact, I'm going to change it to a simpler form, and I'll come back to this. Yeah. All right. I'm just going to fix that, because we can do it a couple ways, and I'm going to show you both ways. But for now, I'm going to show you what may be the easier way. All right, so because we had an action listener, we're promising that we'll have an action performed method, and there it is. Although my indentation is all out of whack. We'll see if, there we go. All right, so there's my action performed, and we're not going to worry too much about what's happening in there yet. The main thing is that we're telling all of these buttons, look, you'll find action performed here. I have my own action performed method. You don't have to go to another object. It's here in this class. That's all that's happening. So we're telling all of the buttons, look, there's an action listener here. You can find the action right here. It's in this class. So we'll set the size so that it's visible. All these things are standard. Now, at this point, as long as you have an action performed, it'll work, but it won't do anything when you click the buttons. Now, in the action performed, of course, we only had one button before, and we only had one action performed. So what did we do? Well, if they click the button, we do something. The problem is there's 4 different buttons that could get us to the same action performed method. So what you'll typically do in this case is the action performed simply does a little bit of, it's like a traffic cop. You, go there. You, over there. That's what it does. And so what it'll do is, remember this action event object that automatically gets passed to us. It is a special object that tells us, well, what action just happened. You can look it up in the Java docs, and you'll find that it has a number of really interesting methods. But one that's real interesting is called getSource. And the getSource method, it tells us, hey, what called us? Which button got us here? So, I'm running it. Okay, I recompiled. Where did you run into an error? Oh, sorry. Yeah, my comment was in the wrong spot. All right, now I'll try it. Compilation completed. Run that son of a gun. All right, so what's happening here is this is calling the local action performed when I click it. This guy's calling local action performed. This guy's calling action performed. This guy's calling action performed. But what e.getAction command does is it tells me which button was pressed. Oh, all buttons go to the same place, but we can query, we can find out, okay, which button got pressed? How did I get here? Okay, that makes some sense. And so we'll take a look and see what our code does here. Well, so command, oh, sorry, no, I want this one. e.getSource tells me which button was pressed. And now we are actually comparing the buttons with each other. This double equal sign, remember what that means is, are they actually the same object? So this is returning an object. And the object is the thing that got clicked. So if the button is equal to button 1, so if button 1 is the one that got us here, well, we'll set the output to uno, that's Japanese, for 1. Oh, I just switched languages. We're in Spanish. Hey, cool. Sorry. Hey, that's fun. Yeah, the other one down here is in Japanese. So, yeah, because I love these languages. Okay, so, sorry, I got a little excited there when I changed languages. So what's happening? So if button 1 was clicked, we'll set the text to uno. If button 2 was clicked, we'll set to dos, tres, cuatro. Okay, so that makes sense, yes? Okay, so that's pretty cool. And this is basically what you do when you have a form that gets more complicated and it has multiple things that can accept action. Is your action performed, we'll just find out, okay, which element got activated here, and then what do I do? Now, right now, I'm actually doing code directly here. As our code gets more complicated, what we'll tend to do is we'll tend to have it go do functions. So we'll have a function for each button, and then all the action performed does is figure out, okay, if this button was pressed, go run this function. Generally, as things get more complex, that's what we do. Now, another approach you can do here, I'll go ahead and comment this out so you can see the other approach I was using, which has its own advantages and disadvantages. The E object, so this event object, also has a method called getActionCommand. And so every action you can set a command to, but in the case of the buttons, I'll run this again, recompile. This time it's going to be back to Japanese. Ichini, san, shi. Okay, so this time Rather than checking which button got pressed, it looked for the action command. Now, in the case of buttons, the default action command is the label of the button. So we can just say, hey, if your button's label is 1, do this. If your button's label is 2, do this. If your button's label is 3, do this. Now, why is this any better than the other approach? Well, it isn't exactly. It isn't necessarily better, but it does have one really interesting advantage. Now, we haven't done it yet, but it turns out we can also add menus. So we could have menus, we could have keyboard commands, and we could have maybe 3 different ways to do the same command. Aha. Each of those we can assign an action command to. And so you could have multiple ways of getting to the same action command. You don't have to actually put the code in every single object. Oh, it's not that important. Use what works for you, but it's nice to know that there are some options here. Hey, this is interesting. In both cases, I had an else clause. Did you notice that? I mean, there's only 4 buttons. How could it possibly be anything but these things? I mean, I created this thing. So it'll never get there. So why did I write that code? Well, because things that should never happen all the time in programming, don't they? Yeah, they do. So we're going to have to assume that it can go wrong, and we'll at least put an error message in place. Okay, so that makes sense. That make sense? Yeah, that makes sense. Okay, so let's take a look at another issue. Let's take a look at starting to add some different kinds of elements. Because right now, the only things we know how to add are labels, text entries, and buttons. Those are good, but we can do more. So let's look at some of the other primary kinds of objects you might want to have. So let's do this one. Come on. There you go. Now, this is a pizza ordering program, and it has 2 really interesting kinds of elements on there. First, it has checkboxes. We can have cheese or not cheese. We can have pepperoni and not pepperoni. Now, the cheese and the pepperoni don't really depend on each other. You could have any combination of the 2. So that's a checkbox. Checkboxes can be checked or not checked. And it really doesn't matter. They don't care about anything else. They're really pretty independent of each other, which seems silly until you compare them to their friends, the radio buttons. Now, this is called a radio button because it reminded the early programmers, radio button. Let's do an actual image in a car radio. So you can't even find the ones in a car anymore. There you go. This is because the older cars had these, in the radio, you had these buttons you could push in to choose a channel, right? And when you push one of these buttons in, the other ones came out. I know, it's so crude. Yeah, it was actually physical, mechanical. You had to press the button. Kind of crazy. And the funny thing is we still use the term radio button, even though almost nobody's radio does this anymore. Now you have these little electronic things. But the term still stayed in GUI development. So that's a radio button. And the thing is, your pizza can't be small and medium and large. It has to be one of these things. So although checkboxes and radio buttons seem to be very similar, they're actually quite different. And really the difference is that these checkboxes, they can be in, they can be independent, they can be in a group, doesn't really matter. Radio buttons only make sense when they're in a group. So they have to be in a group to do anything interesting. So radio buttons have to be in a group. Okay, that makes sense. Now, another interesting thing is, so I've got these new elements. Do I need to attach them to an event handler? And the answer is you can, but we almost never do. Why not? Well, if you think about it, right now I'm just letting the objects do their own thing, right? They're being selected and unselected. I didn't have to write that code. I only want to do something when they actually click the order a pizza button. And it says, what does it say? We ordered cheese, pepperoni, medium pizza. Okay, good. Of course, we can change things Who wants a pepperoni pizza without cheese? That seems horrible. Okay, but in any case, it is responding, but I'm only doing actual response on the button press. I don't actually have to code what happens when they change these guys. Now, you can code that, and I'll show you an example of that a little later, but typically for these guys, you don't. You just write your code in some sort of a, submit button. So a button gets clicked, and that's when we go read these things. Okay, so many interface elements aren't really meant to directly trigger an event, but they're meant to be read after an event is triggered. Okay, so let's see how this is done. It turns out it's not super difficult. All right, so check radio, extends JFrame, implements action listener. This is surprising to no one. You'll look in here and you'll see there is such a thing as a J checkbox and a J radio button. I guess that's not surprising, isn't it? And it also wouldn't be too surprising how you create them. New J checkbox, cheese, checkbox pepperoni, radio button, radio button, radio button. Now these guys, they actually take a label. Now if you're used to doing some of this stuff in, say, HTML and so on, where there are very similar elements, well, they don't have a label integrated. You have to write your own. Is that okay? Sure. Yeah, it's just slightly different, that's all. Now, the big difference between a checkbox and a radio button is that radio buttons have to travel in herds, like, wildebeests and stuff. And so you have to somehow group them. So there's another thing called a button group. And so when we create radio buttons, we also want to make a group that we can put them in. Now, right now, they're not in the group. It's just empty, but we'll fix that soon. Now, I've got a button for the order, and then I've got my container, the content pane, where I'm going to just add all this stuff visibly. Okay, so now we look at our constructor. It's not super complicated. We add everything to the page. There, we've added the check cheese, the check pepperoni. Now, we're going to add the radio buttons to the group. Now, the group is not a visible thing. It's just a logical structure. So we'll add the radio buttons to the group, and then we'll also add them to the page. Now, you could do that in another order. You could do it the other way around. That'd be fine. But we need to add the radio buttons to their own group and to the page. And, of course, if you're doing like a multiple choice test with 25 questions, you're going to have 25 groups. Each group is going to have 3 or 4 buttons in it. All right, that makes sense. All right, now the button, we'll add the button, and anytime you add a button, you're probably going to add an action listener. And then we'll set up the visibility. Now, action performed is going to happen when the button gets clicked. And what do we do? Well, for the checkboxes, we have to check each one on its own because each checkbox could be selected or not. And it has a very clever isSelected method, which is Boolean. It's true if the checkbox is currently selected and false if it isn't. Again, this may be different than how you've done it perhaps in JavaScript or HTML, so don't get too tied up in how you may have done it in another language. But if it's selected, then we say, hey, you ordered cheese. Now we'll look at CHK pepperoni. If it's selected, we'll say you ordered pepperoni. Okay, good. Now we'll check the radio buttons. Now the radio buttons are slightly different because only one in a group will be selected. So we'll do this a little bit differently. If RDO small is selected, then the size is small. Else if medium is selected, the size is medium. Else the size is large. Okay, that's doable. And then we can print that out. So checkboxes, radio buttons are nice. Why do we like these as opposed to simple text areas? What's the advantage of this kind of thing over just letting them type in what they want on their pizza? Well, it has a really significant advantage, and that is this. What if they wanted to put, they wanted to put like bat wings on their pizza or something weird like that, right? We're not going to allow that because we don't have it. Now, if you just let them type stuff in, they could type stuff that doesn't make sense. Oh, so what we're doing here, by using user interface elements, sure, we're making the user's life easier because they're just clicking something rather than typing. But we're also making our life easier, which is a even more important thing, because we're only allowing choices that we can handle. So they can't choose anything but cheese or pepperoni. Okay, and they can't choose anything but small, medium, or large. So by limiting the user choice, we now are much more certain that we can protect against errors, because they can't type something in that we can't handle. Make sense? Yeah, it's a good thing. All right, so that is checkboxes. Okay, let's take a look at what I listed next. Lists. Yeah, we'll do lists. You probably won't need these for this week's assignment, but you might for your final project. So let's take a look at how lists work. First, I'm just going to go ahead and run it so you can see that happening. Takes a second to pop up here. Okay, so we have multiple kinds of what we call listable elements here. So here is a list box: red, yellow, blue. I can choose one. Sometimes you can choose more than one. Yeah, you can. I don't think this is going to respond to that, but that's fine. We also have this drop-down list box, and we have a scroll bar. And when we click it, it tells us what happened. We found red, medium, 56. Okay, good. Interesting. Now, why is it sometimes doing something a little different? I'm curious about that. Yeah, okay, I can tell what's happening. All right, so that's interesting. So what are these things? Well, this is a list box, and it allows us to have more than one item. And the user can choose by selecting one of these items. Okay, that's kind of nice, right? Yeah, that is nice. And it has the same advantage of the whole radio button checkbox thing, in that they can't enter something that we didn't anticipate. So the programmer gives a list of choices, and the user has to choose from those choices. From a software engineering point of view, this is wonderful, because now we're less worried about them typing in something stupid. This is really the same sort of thing, really, except it only takes up one space until the user clicks on it, and then they can have more. This has been popular for a long time, but especially on things like mobile devices where there's not a lot of real estate on the screen. This third thing, I don't know why it looks a little weird on my Mac. I think it'll look different on your other devices. This is called a scroll bar. A scroll bar, you see them all the time, right? It'll look a little bit different on Windows. My Mac is trying to be cute. But the way it typically looks more like this on a Mac. There you go. The way a scroll bar works is really, it's about choosing an integer. So it's about choosing a number within a range. And why is this so useful? Well, users are terrible at entering numbers, aren't they? Yeah, it's just a nightmare. A lot of people are nervous whenever you start talking anything about numbers or math. So a scroll bar is really a way of doing numbers, numeric input, in a way that's immediately visible to the user. And that's really, really useful. It also means that you can determine, as the programmer, the maximum and minimum values, and they can't enter something that aren't in the range you want. So in this case, we've got these three different kind of interface devices, but again, everything really happens when we hit the Click Me button. So let's take a look at what's happening here, and you're going to need to look at the Java docs to learn a little bit about these new items, but they're pretty cool. Okay, so first we've got a J-frame, an action listener, and a J-label. Nothing shocking there. Now this J-list is a little bit interesting, and the reason is because it is, oh my goodness, what does generic is what Java calls this. It's called different things in different languages. A J-list is a special thing, and if you think about it, a list is a lot like an array, isn't it? Yeah, it's like the visual representation of an array. And so a list box is also a representation of an array. Now, what this little notation means, and in earlier versions of Java you didn't see it, it's a relatively recent innovation and a good one. It says the J list is essentially going to be a list box of an array of strings. You can make it an array of other things, okay? But this one's going to be based on strings. So the generic is a powerful mechanism because it allows us to make an object capable of handling lots of different subtypes. We'll come back to that in the more advanced class. If you take the second Java class, we talk a lot more about generics and templates and how powerful they can be. For now, I'm not that worried about them. Now we take a look at this thing, we call it LST color, so I can tell it's a list box containing colors. And now I make a new JList, and because it's a generic, I have to put the little diamond operator, but I've already said what type of thing it's going to be, which means inside it, I make an array of those things. So since I said this is going to be a JList based on string, and they almost always are, then I'm going to put inside it a string array containing red, yellow, blue. Okay, that's good. JCombo box, same sort of thing. Combo boxes can be around a lot of things. Usually they're strings. And so we use the same generic mechanism, and this is going to be based on a string array, small, medium, large. Okay, good. Now the scroll bar, just going to be a scroll bar. Now that has two things. It could be horizontal or it could be vertical. Remember, horizontal is this way, vertical is up and down. A vertical would look silly given the way our layout is set up, so we went horizontal. It could still do it. It would just look really weird. Okay, so now once we have created all these things, adding them is super simple. I'm going to do my old favorite grid layout 01. Add all these dudes on there. We'll add an action listener to the button. Now it turns out combo boxes can also receive an action listener, but you don't need to do that. But the button click me, definitely we can add the action listener to that. Then we set the size, set the visibility, set the default close operation, all that standard. Now action performed is going to happen when we click on the button. So what's it going to do? Well, the list box has this really remarkable method, get selected value. Oh, that tells me what thing got selected. Okay, cool. The combo box also has a get selected item. Now, because it's a combo box, it wasn't exactly sure what type it is, so we'll just say hey, that's a string, just to help it understand what's going on. Okay, so now we have these things, we can just print them out, size and color. Oh, the scroll bar has a get value method, and it wouldn't surprise you that that returns an integer. Of course, does it have other methods that allow us to check to set the maximum and minimum size and to see how much it jumps when you move around? Sure, look all that stuff up. But the main thing is it has a get value method that allows us, well, to get its value. And this is kind of the standard thing you're going to see in all of these components. We can set them up. We can give them some default values. We can load them up with some pre-existing values, and then we can get information out of them. Now, typically, we don't worry about getting information out of them in real time. A lot of times, we'll wait until the user clicks a button, and then we'll get data out of them. And that's what's happening here. Does that make sense? Yeah, it's pretty cool. Let's save it. I don't think I made any changes. Compile and run just to be certain. Oh, yeah, I did make one change, not a huge one. The change I made is I took off the action listener here because we don't really need it yet, and I'll be showing that to you in the next example anyway. Now note that it's possible, especially in an early run, that nothing is selected on one of these, and that's okay, it can do that. So when I change the scroll bar value, it's changing that. When I change any of these things, it's changing. And why do we love these? Well, because again, we can predetermine the things that the user can enter. And so they can't enter something we can't handle. That makes me very happy. Yeah, that's a good thing. Okay, so let me briefly show you a variation of this. And here's this variation. It looks about the same, but let's run it, and it runs slightly differently. So it looks exactly the same. But now, watch down here. Okay, that didn't do anything. Ooh, gave me the output. Is that the only? Oh, and this one, look at that. it changes that number so you can read the number in real time. Ooh. Now this is very, very handy because the scroll bar itself doesn't usually tell you what's going on. So a lot of times with the scroll bar, you'll want to actually be able to see the number. Now what's interesting is these things are happening before I hit the button. Now when I hit the button, it works again. But it seems to be able to change things in real time. Oh, what's happening? Well, here's what's happening. You take a look at the code, it's only slightly more complicated. So the list demo B extends the JFrame and it implements the action listener. That's fine. Now it also has what's called an adjustment listener. Now an adjustment listener is different. Action listener listens to an action, and the most typical action you've heard is we press a button. Right? Good. Now, but that is a very discrete kind of thing. It's not pressed, it's not pressed, it's not pressed, it's pressed. Right? Adjustment listener is different, and that's most commonly used in something like a scroll bar, because a scroll bar doesn't just, it changes. It changes very rapidly. So there's a lot of continuous change. As we're looking at other things like reading the mouse and so on, it's got its own listener because its type of listening is very different than what happens in just an action. So, you know, mouse motion is very similar to what happens in a scroll bar. It's something that can happen continuously. And it can be a little expensive, right? So you don't want to do it if you don't need it. So let's take a look. By expensive, I mean in the CPU. It costs CPU cycles. It's not like, it'll cost you $5 every time you use it or something. All right, so the main set out of this thing is exactly the same, but take a look at this. The button click me, add action listener, this, yeah, no surprises. Combo size, that's that combo box. Turns out we can add an action listener to that as well. Oh, that's nice. And the scroll bar, we can't add an action listener to that, but we can add an adjustment listener. Okay, so the action listener, you already know what that does. When you do an adjustment listener, now you are required to add another method, adjustment value changed. And again, that's a little bit different than an action, but it's still not hard, right? You just add another function, and you know by the docs exactly what function you should add. It needs to be adjustment value changed, and it will have an adjustment event we normally call E. Okay, so now we look at the action performed, and it's exactly like it was before. The only difference is this time it actually does read an action from the combo box as well as from the button. And then the adjustment value changed. This gets selected every time we change the scroll bar. And all it's going to do is get the value and then copy it out to that output label. Oh, yeah, that makes a lot of sense, doesn't it? Yeah, do you think you could do some interesting things here? Yeah, you can do a lot. You already know quite a bit that you can do with these things. Okay, so we got one more demo to look at today, and this is Dialogs. Let's go ahead and compile this, and I'll show you what I mean by Dialogs. They are the best and worst things in Java, I think. Okay, so here's an information dialog that pops up. Here is some information. What do we think about these? When we run across these little pop-ups like this, you like these? Come on, be honest. No, you hate them, don't you? Yeah, they're annoying. So why does a programmer use them? Well, there's two reasons. One, they're very easy. But another reason is that they interrupt the flow of the program. In fact, I think I can't go back. All right, I can't do anything with my main program until I actually acknowledge this one. So it stops the flow of the program. That might sound great to you as a programmer, but as a user, it's really annoying. So this is called a modal dialog, and that means it stops and it does not allow the program to proceed until the user acknowledges the button. So you should use it sparingly because users find them very annoying. But now I can get back to the main program. And input is similar, but it allows you to type something in. Andy, nice to meet you, Andy. Now, again, since we're already in a GUI, we can do it better. We don't need these modal dialogs, but it's occasionally handy. A couple of you used them before already, and that's fine. These two types of dialogue, the information and the input, I don't love them. I rarely use them in actual Java programming. It's pretty uncommon. But the next two, I love. Check this one out. Ooh, a color. There's my new background color. You like it? I chose it just for you. Okay, now we're going to do this color. Ooh, that's really cool. Now, this is also a modal dialog. It means it will require you to hit OK or one of these buttons before we can get back to the main program. But in this case, it makes a lot more sense. And what's interesting here is that that'd be a lot of work to write this thing. Look how complicated it is. You can choose from colors from a list. If you like the HSV or the HSL color models, you can use those if you know what they are. RGB is one you probably know a little bit better. So we can use RGB color model to pick a good color. There we go. We've got like a tan going on. This is actually technically RGBA, so we can also choose transparency. And then it gives us like the hex color code you'd use in HTML. That's really cool, right? CMYK, we use this for printing. Yeah, this is really great stuff. And it would be pretty hard to program this, right? You don't have to. That's the beautiful part, is this color dialog is built in to Java. It's built into Swing. And so if you want the user to choose a color, getting them to choose a color that's really legal is very difficult, right? But this thing is built in. You just pop up this color dialog and use it to ask them what color they want. That's pretty awesome. It's very awesome. Here's another one that's maybe even more awesome. And this is the dialog, the file dialog. Let's go to my desktop and let's go find dialogs.java. I open up that file, and of course it's not doing anything with it, but I could have it open up into an editor. I could print out the values and so on. So I can grab any file that I can find and do something with it. Whoa, that's crazy. Yes, it is crazy, and it's really cool. All right, so let's talk about how this code is written. It's really pretty straightforward. It's a JFrame, implements action listener, and it has some buttons just so I can call up these various dialogs. And then we add them, add action listener, nothing shocking. Everything interesting happens in action performed. So if they press the info button, then J option pane, that's the name of this class that contains a number of interesting dialog boxes. It has a show message dialog. Now that has to have a parent. It needs to know what it belongs to. So where does it go back when it's done? And it can take two strings. One is the information, and then this is the title. So it's a quick way of showing text. Again, in a GUI, you're probably better off not using that. This last thing is the icon that it displays. So it actually is showing that cute little exclamation point that normally you'll see. Oh no, I'm sorry, it's that. In some languages it's something different, but that's what it's showing as its little icon. Not that helpful, but that's there. Now if they do input, that's almost the same thing. It's the J option pane show input dialog. But the input dialog doesn't simply do something. It asks for some value, and then it returns that. So the input dialog is going to ask the name, and it's going to return a string that we'll put in a variable. Now we can use a message dialog to greet the user. Nice to meet you, name. Okay, that's kind of neat. All right, so what about this one? If they press the button color, well, there's a JColorChooser object, and it has a show dialog method. Again, it's pretty straightforward. What panel does it belong to? What's its title? We could make it more interesting than that. Please pick a color and a default color to start with. And then once that thing runs, it passes back whatever color the user chose, and I can do something with that as a legal Java color. Wow, that's so cool. And the FileChooser is perhaps my favorite of these. Because getting the user to give you a file name that's legit is really difficult. First of all, you don't know what files are on their computer, so it's really hard to know. It has to go and it looks at the computer and it figures out what files are there and allows them to change directories and allows them to filter by type and all those kind of things. That's really crazy, right? Well, the good news is that's built in. There's a JFileChooser object. This is in javax.swing or java.auth. I don't remember, but since I always import them both, it doesn't matter. So the JFileChooser, that's got several dialogs. There's a show open dialog, show save dialog, show save as dialog. They're all pretty similar, but if you remember, when you use those different commands in your programs, they have slightly different behavior. Basically, we can show an open dialog, and that returns a value. Now, this value, it just tells us what happened, what was the status, and were they okay. If they said, yes, I want to move on, then the status is approve option. And now we can get that file that they selected. And we'll be talking about I/O next. We're going to be talking about saving and loading files. But now we have a file we can work with that we can do something interesting with. Okay, well, we can get its name, for one. Okay, and we'll just print out you chose that name. Now, next week, when we learn how to actually open up files, we can read data from the file, put it in local data structures, we can save a file, we can build a text editor, we can do all kinds of crazy stuff. But essentially, you don't want to actually have to deal with file names. It's much easier to work with a FileChooser object so that the user can use a familiar mechanism to save and load files. Now, you still have to do some of the work. It's not hard. But in terms of choosing a file, the FileChooser just makes your life so much easier. Man, we used to not have that, and it was kind of awful. So it's a pretty great thing. Okay, so I'm feeling pretty good about things today. Let me talk about our next project. And this one will be, I think I'll make this your last project besides the final. And it's not going to be super hard. So let me explain what it is we want to do. We're going to do what's called a body mass indicator. So a body mass indicator, it's a tool for determining, you know, somebody's. Oh, sorry, I didn't make that actually a link. Let's try and fix that. So here it is. Sorry, I'll make it a link if I can remember. So here's body mass indicator, and what it is a formula designed to help indicate how healthy somebody is based on their weight and their height. Now, I'm going to not even worry about the fact that this may not be a terrific calculation. It may or may not be a good solution. We've seen much better. But what we're really interested in is this is a very easy program to make a calculator for. Now, since you guys are in the civilized world and use the metric system, BMI is very easy to calculate. You just simply take the weight in kilograms and you divide it by the height in meters squared. Now, for those of us in the United States who insist on doing things the right way, then you have to take the weight in pounds divided by the height in inches squared and multiply that by a scaling factor, which converts it basically to metric. Okay, so what you're going to do is you're going to write something kind of like this. You don't have to worry about the units. You can choose metric or imperial if you wish. If you want as a black belt to add that, that's fine. But you're going to take in the weight and the height, and you're going to calculate the BMI. You don't have to show all this. You'll just calculate the BMI, and then you're also going to calculate what the meaning is. So if the BMI is less than 15, you'll say, whoa, you're way skinny. If it's between 15 and 16, yeah, you're pretty skinny. You're skinny. You're normal. A little heavy there, and on the go. All right? So you can do, so what you're going to do is you're going to make something kind of like this. Does that make sense? So you're going to write a little Java program that basically does these things. If you want to go imperial, that's fine, but you do pounds and inches. Does that make sense? Yeah. It's pretty simple, really. It's not super, super complicated. In fact, I thought I have a version of it working online. You can see. So here's a version I did in JavaScript. So height in inches, 72, weight in pounds, 170. Calculate BMI. Whew, thank goodness I'm normal. That works, right? Yeah, that's basically what you're going to do, but you're going to do it in Java. Does that make sense? So here's some tips. You're going to want a subclass JFrame. Yeah. You're going to sketch out the user interface. I'm expecting it to be not just a simple stack. You should probably do something slightly more complicated for a good grade than just one column. Think through the layout. You're probably going to want some kind of nested layouts. Think what events you're going to need and what elements are going to respond to events. Here's a big tip. You don't need any of the stuff we did this week. Not really. Write a function to read the input, create the output. Remember, you're going to have two outputs. One's just going to be the BMI, and then the other one is going to be the status. You could put that in a single label. You could put that in two labels. You can do what you want for this. Does that make sense? And the main point of this is not to calculate BMI. The main point of this is to make sure that you can build a graphic user interface, because now we're going to start talking about data and your final project. And I want you to be able to use a graphic interface for your final project if that's something you want to do. Does that make sense? Yeah, that makes sense. Okay, so we'll be working on this. I am finishing the grading of the crypto labs, and I'm starting the card games, so hopefully I'll have those by next week. And then let's take a look at getting this done, and we're going to start talking about your final project. You're going to have to build something. Yeah. All right, you guys are awesome. Thank you. Take care.